Welcome to the video, continuing on with our look at confidence interval problems. Let's look at a problem in which we're estimating a population mean using a confidence interval with the population standard deviation unknown. Here we have a problem. Let's see what they want us to do. We're told that it's common to see feral cats transiting a certain backyard. A recent sample of 25 days, so anytime we see sample in statistics, our pencil should perk up, and sample of 25 days found that an average, so the average of those 25 days, or the sample mean, was that 30 cats transited daily. The sample's standard deviation is 10 cats. So here, this standard deviation explicitly refers back to this sample, so therefore we know that that is a sample standard deviation as opposed to being the population standard deviation, which would be every day that has been in that backyard, how many cats have gone through it. Also here, we're told to assume the daily number of feral cat transits follows a normal distribution. That's important here because one of two assumptions must be met. Either our sample size must be 30 or higher, which in this case it's not. Lacking that, we need to know that the underlying population of the sample has a normal distribution. Here we're told that the daily number of cat transits, which implies the population, every day's number of transits, follows a normal distribution. So that's going to get us into using our standardized normal distribution. In this case, it's going to be the t distribution because we're working with a sample standard deviation and we don't have the population standard deviation available. Here we're asked to come up with a 90% confidence interval of the daily number of cat transits through that backyard. So let's go ahead and start to sketch this one out. So we've checked our assumptions. They are covered because we know the underlying population distribution is normal because the question told us that. So now we're looking at a two-step process. Why don't I go ahead and take our sample mean and make that the center point of this confidence interval. So the center is going to be 30 cat transits. If we were to make a point estimate of the population number of daily transits, that estimate would be 30 because that is the best data that we have to work with. But we're asked to work that into a 90% confidence interval. So therefore, interval says come up with two values, a lower boundary value and an upper boundary value, and that's what we're going to do here. So let's go ahead and jot down the formula here to come up with the appropriate margin of error. And that formula in this case is going to use the t alpha half or t distribution because of the fact that sigma is not known here. So we're going to be looking at t alpha half multiplied by the standard error of this distribution. That will break down to t alpha half multiplied by sample standard deviation divided by square root of sample size. So first thing we'll do then is come up with the appropriate t alpha half value. So in finding t alpha half, similar technique to z alpha half, in that the first thing we'll do is compute our alpha value. So here alpha is 1 minus the 90%, alpha is 10%. So what's half of that alpha? Half of alpha is 5%, and that is the area in one tail. So what we're going to do is we're going to come up with our degrees of freedom, and let's jot that over here. So the t alpha half we need to have the degrees of freedom for. Degrees of freedom is always the sample size minus 1. So in this case, we have a degrees of freedom 24. And the second component of T alpha half is that the area in one tail is equal to that 5% half of alpha. So knowing those two factors, let's go to our T-chart and we'll find the corresponding row for degrees of freedom 24, and we'll line that up with the correct column representing our area in one tail. Here we figured that out to be 5%. So 5% area in one tail, 24 degrees of freedom, gives us a T alpha half of 1.711. 1.711 for that T alpha half value. So knowing that, we can fill that into our margin of error formula, and now we'll just need to finish this up by including the standard error ratio here. So S, which is our sample standard deviation, is the numerator of that fraction. Square root of n is the denominator, square root of 25, and that's going to give us 1.711 times 10 over 5, or 1.711 times 2, and we'll go ahead and compute that. We'll round it to 2 decimals, so 3.42. We now know that our margin of error that's appropriate to use here is 3.42 cat transits. So the second and final step of completing this confidence interval is to take our sample mean and add and subtract that margin of error to it to get the upper and lower boundary points. So here we know that the average number of cats transiting per day, or the sample mean from our sample, is 30. So that is the center point of this confidence interval. And to that, we will first subtract and then add the margin of error that we computed. So 30 plus or minus 3.42 gives us a final confidence interval, in this case of 26.58 on the lower boundary and 33.42 cat transits on the upper boundary. So in conclusion, with 90% confidence, we can expect that between 26.58 and 33.42 cat transits will occur on any random day through that backyard. Thanks.